So in this lecture, we're going to clarify the concept of rotation and vorticity. So although mathematically they look very similar to each other, so you have omega equal to 1/2 times vorticity, half of the vorticity, or we can also say that vorticity is equal to twice omega, right? However, when you watch this, when you look at this, although mathematically they are the same, they're different concepts. Vorticity is nothing. This is nothing else than this is the curl. This is known as the curl of the velocity field. And it is also known as the measure of the local rotation of the fluid. Okay? Now, rotation this is vorticity. And the rotation that has to do nothing else than is the measure of the rotation of the finite area of the fluid. The concepts are very, very different to each other. So if you are asked, let me explain a bit here what I mean by rotational. So you can see here, you have a very small element area that represents that amount of fluid. When it goes to point A to point B, that element rotated, you see? So you have to say that the fluid is rotational, right? Because that means that has the capability of rotating. This is rotational fluid. But when I talk about rotational fluid, I need to use omega to say that and not big omega that talks about vorticity. Okay? This is irrotational. And I need to use, again, omega, not big omega for this. And it will be irrotational if this is actually equal to 0, rotational if it's different from 0. So it's important to understand this difference and never confuse that, yeah, there's a tendency of saying, oh, you know, really I'm using vorticity. So if I just use vorticity, I can answer the question if it's rotational or not. Well, if you're talking about rotational, then we need to talk about big, small omega. If I'm talking about the capacity of that fluid to generate a vortex, maybe a vorticity, the involvement of vorticity, then I'm saying, hey, this is a vorticity, right? I'm generating a vortex. So it has the capability of doing a vortex. So this is a vorticity. Okay, that vorticity, the capacity of the vorticity is measured by twice the rotation of omega. It is correct, however, that I can say, I want to simplify all my math, evaluate everything in terms of omega, big omega, this is vorticity. And then from here, I can say, because I don't want to carry this 1/2 everywhere, right? So then I can go ahead and say, you know what, to simplify my life, I will do everything in omega, then I will just multiply by 1/2. The vice versa is true as well. What happens if I already know what my rotation is, or my small omega? Then I don't have to recalculate anything, just multiply by my 2 times small omega, and I can talk and I can answer the questions of vorticity. Here I answer the questions on circulation. I hope this clarifies the concept of circulation and vorticity.